Question 8 is for a sequence if Sn is 2 into bracket 3 raised to n minus 1. Find nth term. Hence show that the sequence is in GP. Now, they have given you Sn. It is 2 into 3 raised to n minus 1. They want Tn and also the sequence. Now, if this is Sn and if I say S1, S1 means what? Sum of first term. That will be first term itself. So S1 will be 2 into 3 raised to 1 minus 1. That is 2 into 2. Answer is 4. So the first term of the sequence is 4. Now S2. S2 is sum of first two terms. That is T1 plus T2. So I'll put S2 in place of this. 2, 3 raised to 2 minus 1. 2 into 9 minus 1. 2 into 8, it is 16. Okay, now S2 is 16, but S2 is T1 plus T2. So 16 is 4 plus T2 and T2 will be 12. See, S is sum of the first terms. Sn is for sum of first n terms. तो अगर मैं S1 बोलूं तो वो हो जाएगा sum of first term. Sum of first term is the first term itself. पहले टर्म की एडिशन तो पहला टर्म ही होगा. पहले दो टर्म की एडिशन T1 plus T2 होगा. Now next, पहले तीन टर्म की एडिशन S3. It is 2 into 3 raised to 3 minus 1. That is 2 into 27 minus 1. 2 into 26. 26 twos are 52. S3 is T1 plus T2 plus T3. So 52 is 4 plus 12 plus T3. So 52 will be 16 plus T3. T3 will be 52 minus 16. 36. So there is one more method of finding out this. Tn is Sn minus Sn minus 1. We can put n minus 1 here and find out. But this procedure can be too big. So ये थोड़ी सी simple हो जाती है. तो वो क्या हो जाएगा? तो Sn minus 1 will be 2 into 3n minus 1 minus 1. Then you will subtract them. So Tn will become 2 3 raised to n minus 1 minus 2 3 raised to n minus 1 minus 1. फिर इसको सॉल्व करते बैठो. तो कभी कभी ये बहुत लंबा प्रोसीजर हो जाता है. इससे अच्छा हम लोगों ने ये तीन टर्म्स निकाल लिए. सीक्वेंस क्या आया? 4 12 36. Now, is it in GP? 4 12 36, is it in GP? Yes. 4 12 36. It's 4 into 3, 12 into 3. It is in GP. So for GP, 12 by 4 is 3 and 36 by 12 is 3. So 4 12 36 is in GP. So Tn will be A r raised to n minus 1, 4 3 raised to n minus 1. This is your Tn. So the question was you have to find Tn, that is n term, and also show that the sequence is in GP. So yes, we have found that it is in GP, and also we have found the nth term. इसका alternative method ये हो जाता है, you can use this formula that Tn is Sn minus Sn minus 1. Sn minus 1 will be 2, 3 raised to n minus 1 minus 1. So Tn will be 2, 3 raised to n minus 1 minus 2, 3 raised to n minus 1 minus 1. 2 into 3 raised to n minus 2 minus 2 into 3 raised to n minus 1 plus 2. This will get cancelled. This is 2, 3 raised to n minus 2, 3 raised to n into 3 raised to minus 1. 2, 3 raised to n common. 1 minus 3 raised to minus 1. 2, 3 raised to n. 1 minus 1 by 3. This will be Tn 2, 3 raised to n. 1 minus 1 by 3 is 2 by 3. That is 4. 3 raised to n upon 3. 2 into 2 is 4. And this is 4. 3 raised to n into 3 raised to minus 1. That is 4, 3 raised to n minus 1. So this and this, it is same. Now once you will get Tn, you can find out your GP, the sequence putting n as 1, n as 2, n as 3, and show that it is in GP. ये एक अल्टरनेटिव मेथड है, तो मैं T1 निकालूंगी. 4, 3 raised to 1 minus 1. 4, 3 raised to 0. 4, this is T1. T2, 4, 3 raised to 2 minus 1. T3, 4, 3 raised to 3 minus 1. आ गए terms. 4, 12, 36. This is in GP because they have common ratio. This is an alternative method. आप ये method से करो या alternately आप इस method से करो. If S, P, R are sum, product, and sum of the reciprocal of n terms of GP, respectively, then verify that S upon R raised to n is equals to P square. Question number 9. If S is sum of n terms of GP, now I'll say let A be first term and R common difference of given GP. So the GP will be A, AR, AR square, and so on. Now S is sum of n terms of GP. So it is nothing but S is nothing but Sn. Sn depending on the value of R. So let us assume that R is greater than 1. So Sn will be A, R raised to n minus 1, R minus 1. Then what is P? P is product of n terms. P is A into AR square into AR cube into so on up to a r raised to n minus 1. So here it will be a is multiplied for n times, so it will be a raised to n, and r into r raised to 2, r raised to 3. So it will be r 1 plus 2 plus 3 plus so on up to n minus 1. Now see, there is one theory that we should know. Sum of first n natural numbers. Sum of first n natural numbers. N natural numbers are in AP. 1, 2, 3, so on up to n. They are in AP. Their sum is given as n minus 1 by 2. So I can write down this as a raised to n, r raised to, this is also sum of n natural number, n minus 1 upon 2. If I say p square, because I have to prove something in p square, right? I have to prove something in p square. So if I say p square here, this is p, then p square is a square, that is 2 raised to n, r n into n minus 1. This 2 will get cancelled. Iska square ho jayega na? So this will be a raised to 2n, r raised to n into n minus 1. We've used this property. Sum of first n natural number is given as n minus 1 by 2. Now these are also first n natural numbers, so we have taken this. So we have got s, we have got p square rather. Now r, capital R. Capital R is sum of the reciprocals. Reciprocal is 1 by plus 1 by AR plus 1 by AR square plus so on up to 1 upon AR raised to n minus 1. This is the case. Now A is common denominator, but R, so I want here R raised to n minus 1. Plus here it will be 1 R is there, so R raised to n minus 2 plus R raised to n minus 3. This will go so on up to R plus 1. And this will be a r raised to n minus 1, common denominator. Now this is nothing but 1 plus r square plus so on up to r raised to n minus 1. इसको ही अगर मैंने उल्टा लिखा तो, and this is a r raised to n minus 1. Take this numerator, 1 plus r square plus r cube, so on up to r raised to n minus 1. This is in GP with a1 and r is r. So what is the addition of this GP? 1 r raised to n minus 1 upon r minus 1. It is r raised to n minus 1 upon r minus 1. I'll write down here. This is 1. I'll put it here from 1. This is r raised to n minus 1 upon r minus 1. Whole thing upon a r raised to n minus 1. Will not cut this, because cutting is not going to give us any option. Okay. Now what is S? S was a into r raised to n minus 1 upon r minus 1. So I will multiply here by a, here by a. So r is a, r raised to n minus 1 upon r minus 1 upon, this is a square, r raised to n minus 1. Is this S? So r is equals to S upon a square, r raised to n minus 1. I can write a square r raised to n minus 1 is equals to s upon r. I have to prove s upon r bracket raised to n. So we will take nth power on both the sides. So here it will be a square r raised to n minus 1 raised to n s upon r raised to n. जैसे हम लोग स्क्वायर करते दोनों साइड को, तो हम लोगों ने n पावर ले लिया दोनों साइड पे. It is taking n power on both sides. तो ये मल्टीप्लाई हो गया, ये हो गया a to n r raised to n into n minus 1 is equals to s upon r raised to n. This is nothing but p. See here, p square. This is nothing but p square is equals to s r raised to n. Proved. ये एक्चुअली तो प्रॉपर्टी है, लेकिन इन्होंने सम में दी है, इसलिए हम लोगों को इसे प्रूव करना पड़ा. अदरवाइज सारी प्रॉपर्टीज हम लोग प्रूव नहीं करते हैं. Again, I will again come with this. See, if the GP is A, AR square, and so on. So what is Sn? A into r raised to n minus 1 upon r minus 1. P is product of all the terms. So if we multiply, A is getting multiplied by n times, and r is getting multiplied for n times. So r will be 1 plus r square plus r cube and so on. So it will be r raised to 1 plus 2 plus 3 plus so on. Now here I have used a different method. Is sum of first n terms, sum of first n natural numbers is n into n minus 1 by 2. वो इधर लिख दिया हम लोग. ये एपी का फॉर्मूला था. ये जो फॉर्मूला है, क्योंकि नेचुरल नंबर्स एपी में होते हैं, तो ये एपी है. एपी के हिसाब से अगर इसका आप सम निकालो तो आपको n into n minus 1 by 2 मिलेगा. तो हम लोगों ने इसको स्क्वायर कर दिया, तो वी हैव गॉट a raised to 2n r raised to n into n minus 1. p square आ गया. Now r, this is big thing. R is a sum of reciprocal 1 by a plus 1 by ar plus 1 by ar square plus so on. Now a is a common denominator, but see here I don't have r raised to n minus 1. So I'll multiply here by r raised to n minus 1. इथे एकच r येतं, r raised to n minus 2 multiply with n minus 3 multiply with, like this will write down. इसी को मैंने उल्टा लिखा, तो ये होगा 1 plus r square so on up to r raised to n minus 1. This is again GP numerator. तो इसका एडिशन क्या हो गया? r raised to n minus 1 upon r minus 1. We have returned that. Now if I multiply by a, I will get here s, because that's what I want to prove. S upon r. So we have multiplied by s. So this a. So this will become s, and this will be a square r raised to n minus 1. Putting this on that side, we have got s by r. Taking nth power on both the sides. S by r bracket raised to n nth power का घेतली कारण टेस्ट प्रूफ करायचंय. n से मल्टीप्लाई हो गया. You have proved the sum. बहुत ही स्पेशल टाइप का सम है ये, वन ऑफ इट्स काइंड. 10 sum. If Sn, S2n and S3n are the sum of n, 2n, 3n terms of GP respectively, then verify that Sn into S3n minus S2n is equals to S2n minus Sn bracket square. Question number 10. Sn is sum of first n terms of GP, right? So obviously Sn will be a r raised to n minus 1 upon r minus 1. Wherever they have not mentioned whether r is greater than 1 or less than 1 or whatever, we can always take r is greater than 1 and write down this. क्योंकि अगर ये r is greater than 1 के लिए प्रूव होगा, तो r is equals to less than 1 के लिए भी सेम प्रूव होगा. Then S2n is sum of 2n numbers. So it will be a r raised to 2n minus 1 upon r minus. S3n is sum of 3n terms of GP. So this will be A r raised to 3n minus 1 upon r minus 1. Now what we need to prove? Sn into S3n minus 2n. तो हमको प्रूव करना है Sn into S3n minus S2n is equals to S2n minus Sn bracket square. तो हम लोग पहले ये ले लेते हैं LHS. तो Sn S3n minus S2n. Sn is A r raised to n minus 1 upon r minus 1. S3n हम लोग एक एक करके अगर सॉल्व करेंगे तो वो ज्यादा अच्छा रहेगा. तो हम लोग पहले S3n minus S2n निकाल लेंगे. तो S3n minus S2n, that is A r raised to 3n minus 1 upon r minus 1 minus A r raised to 2n minus 1 upon r minus 1. We can take A upon r minus 1 common. A r raised to 3n minus 1 minus r raised to 2n. This is plus 1. This and this will get cancelled. You can take r raised to 2n common. So you will get A r raised to 2n upon r minus 1 and inside the bracket r raised to n minus 1. Okay. This is 3n minus 2n. Now we'll multiply it with Sn. So Sn multiplied by S3n minus S2n. A r raised to n minus 1 upon r minus 1 multiplied by A r raised to 2n r raised to n minus 1. It's r raised to n minus 1 whole thing upon r minus 1. ये इससे मल्टीप्लाई होगा तो ये होगा r square r raised to 2n r raised to n minus 1 bracket square upon r minus 1 bracket square. This is your LHS. Now let us solve for RHS. RHS is S2n minus Sn bracket square. S2n minus Sn bracket square. So S2n is A r raised to 2n minus 1 r minus 1 minus A r raised to n minus 1 upon r minus 1. We'll again take A upon r minus 1 common into bracket r raised to 2n minus 1 minus r raised to n plus 1. This and this will get cancelled. It is A upon r minus 1. R raised to n is taken common. You will again get r raised to n minus 1. Now squaring this, S2n minus Sn bracket square is A r raised to n minus 1 upon r minus 1 bracket square. It is A square r raised to 2n r raised to 1 n minus 1 square upon r minus 1 bracket square. This is your RHS. Now your LHS is equals to your RHS. Proved. This is also one of its kind. Too big. Next concept of GP is sum of infinite series. or which is also called as sum up to infinity, sum of infinite terms of GP, or sum up to infinity. Now, if R is less than 1, or if I'll say R is in between +1 and -1, only then sum up to infinity for GP exist. So if value of R is in between -1 and +1, सिर्फ तभी सम अप टू इंफिनिटी एग्जिस्ट करता है, नहीं तो वो नहीं एग्जिस्ट करता. तो अगर गिवन सीरीज में आर अगर प्लस और -1 के बीच में है तो ही सम अप टू इंफिनिटी एग्जिस्ट करता है. तो सम अप टू इंफिनिटी इज a अपॉन 1 माइनस r. अब ये तभी एग्जिस्ट करेगा, नहीं तो ये एग्जिस्ट ही नहीं करेगा. फॉर एग्जाम्पल, इफ माई सीक्वेंस इज 2, 4, 8, 16 and so on, and here r is 2, so here sum up to infinity does not exist. लेकिन अगर मेरा सीक्वेंस है 1/3, 1/3 square, 1/3 cube, and so on, so r will become 1/3. 1/3 कैसे हो गया r? देखो 1/3 square upon 1/3, so it is 3 upon 3 square, it is 1/3. r 1/3 means r is 0.33, so r is less than 1. So now sum up to infinite series of GP, the sum up to infinity, this is infinity, exist. And that sum up to infinity is a upon 1 minus r. So 1/3 upon 1 minus 1/3. And we can calculate this further. So 1/3 upon 1 minus 1/3. 1/3 upon 2/3. 3 cancel, your answer is 1/2. Agar r, if r is greater than 1 or r is less than -1, then sum up to infinity does not exist. The very important concept. Now 4.3 is based on the same concept. We'll do 4.2 tomorrow, 4.3 tomorrow.